All right, folks, let's do another example. What example is this? Am I even numbering them? Not even numbering them. Jeez. Noob. Example 2. Decompose the following expression. Well, first thing I'd like to say here is that the degree of the numerator is 3 and the degree of the denominator is 4. So this is, in fact, proper. So there is no long division needed. And we can begin to decompose. Now, this is negative x cubed minus x squared plus x minus 1 divided by x cubed times x minus 1. So we have some repeated factors. Let's see, maybe I should point that out. This is a repeated linear factor. And this will decompose as a over x plus b over x squared plus c over x cubed as I exhaust the multiplicity, and then finally some kind of d over x minus 1. So let's see if we can't figure out what a, b, and c are. We're going to take this equation, negative x cubed minus x squared plus x minus 1 divided by x cubed times x minus 1. Set that equal to a over x plus b over x squared plus c over x cubed plus d over x minus 1. And we're going to take that entire equation and we're going to multiply through by the LCD, which is x cubed times x minus 1. That's the LCD. We're going to multiply by that guy. And what we're going to get when we do that is, on the left, we're going to get negative x cubed minus x squared plus x minus 1 as the entire denominator cancels. And then for a, we're going to get 1 power of x to cancel. We'll be left with x squared. I don't need parentheses there. X squared times x minus 1 plus b times x, x minus 1, plus c times x minus 1 plus dx cubed. Using the strong sense of equality, we're going to multiply this all out and we get a x cubed minus ax squared plus bx squared minus bx plus cx minus c plus dx cubed. And when we group our like terms, we have an a plus d x cubed, and we have a negative a plus b x squared. We have a negative b plus cx, and then we have a negative c for our constant. And so equating coefficients, a plus d must be negative 1. Oops, that's not what I wanted to do. A plus, stop it now. A plus d is negative 1. Negative a plus b is also negative 1. Negative b plus c is positive 1. And negative c is equal to negative 1. So let's write out our equations here. A plus d equals negative 1. Negative a plus b equals negative 1. Negative b plus c is equal to 1. And negative c is equal to negative 1. So this tells me c equals 1. And if I plug that information into the row above, I get negative b plus 1 is equal to 1, which means that b is equal to 0. Now that means negative a plus 0 is equal to negative 1, which means a is equal to 1. And if a is equal to 1, then 1 plus d is equal to negative 1, so that d is equal to negative 2. And there's my coefficients. And that means, we'll just duplicate this here. This is equal to, let's see, 1 over x plus 0 over x squared plus 1 over x cubed minus 2 over x minus 1. So that whole term's 0. It turns out that, as per our original discussion, this doesn't even use all of the exhausting factors. And when we integrate this, I should probably just write this as x to the negative 3 minus 2 over x minus 1, which indicates that the integral of negative x cubed minus x squared plus x minus 1 over x to the 4th minus x cubed dx is equal to the integral of 1 over x plus x to the negative 3 minus 2 over x minus 1 dx, which is the natural log of the absolute value of x, plus x to the negative 2 over negative 2, minus 2 natural log of the absolute value of x minus 1, plus c, or the natural log of the absolute value of x over x minus 1 squared, minus 1 over 2x squared plus c. And that is our result.